Scene script. Have you ever wondered what it would be like to travel back in time? Time travel, a concept as fascinating as it is perplexing, has long captivated our collective imagination. From H.G. Wells' Time Machine to the DeLorean and Back to the Future, we have all been intrigued by the idea of revisiting the past or peeking into the future. But time travel isn't just a staple of science fiction. It's a serious topic in the realm of theoretical physics. Scientists have spent years studying and debating the feasibility of time travel, and while we are still far from hopping into a time machine, the idea isn't as far-fetched as you might think. In the world of physics, time isn't a straight line. It's more like a fabric, interwoven with the three dimensions of space to create the four-dimensional reality we inhabit. This fabric, known as space-time, can be bent, stretched, and according to some theories, even looped back onto itself. Now don't get too excited. This doesn't mean we can go back in time to have tea with Shakespeare or warn the Titanic about that iceberg. Theoretical physics is a far cry from the time-hopping adventures we see in movies. It's less about physically traveling through time and more about understanding how the universe works on a fundamental level. The concept of time travel in theoretical physics is often tied to the idea of wormholes, bridges through space-time that could, in theory, allow us to bypass the normal flow of time. But wormholes are just one of many theories. Others involve cosmic strings, exotic matter, and even quantum mechanics. So while we can't pack our bags for a trip to the Jurassic period just yet, the idea of time travel isn't entirely out of the question. It's a fascinating puzzle that scientists are still trying to solve, one that could reshape our understanding of the universe and our place within it. You see, time travel isn't just a figment of our imaginations, it's a serious topic in theoretical physics. Ever heard of quantum entanglement? It's something that sounds straight from a sci-fi novel, but in reality, it's a cornerstone of quantum mechanics. Now, let's take a moment to break down this complex concept into something a bit more digestible. Imagine two particles that have interacted with each other. Quantum entanglement is a phenomenon where these two particles become intrinsically linked in such a way that the state of one particle immediately influences the state of the other, no matter how far apart they may be. It's as if these particles are communicating faster than light. Now that's some real-life sci-fi for you. So you might be wondering, what does this have to do with time travel? Well, hold on to your hats, because things are about to get even more interesting. Theoretically, it's possible to use quantum entanglement to simulate what might happen if someone could travel back in time. By manipulating one particle, we could potentially alter its entangled partner's past state. Now, we're not talking about physically going back in time, but rather simulating the effects of what could have happened if we could. This simulation could allow scientists to retroactively change the parameters of their experiments. Imagine being able to improve the results of your experiment, not by changing your present actions, but by altering what you did in the past. This idea may sound a bit mind-boggling, but remember, we're in the realm of theoretical physics here. While most of the fundamental laws of physics have no issues with the direction of time, they have what's known as temporal symmetry. The idea of particles traveling backward in time is still a hot topic of debate among physicists. However, numerous simulations have been conducted to explore how these space-time loops could behave if they do indeed exist. These studies are pushing the boundaries of our understanding of time and space, and who knows, they might one day lead us to new and exciting discoveries. Quantum entanglement could be our ticket to the past, at least in simulations. And while we're far from hopping into a DeLorean and changing history, the possibilities that quantum mechanics presents are truly fascinating. So, how can we simulate traveling back in time using quantum entanglement? Well, to understand that, we first need to grasp what quantum entanglement is. Imagine a pair of particles that have interacted in such a way that their states become inherently linked. This connection persists even when they're miles apart. A change in one immediately affects the other, a phenomenon Albert Einstein famously dubbed spooky action at a distance. Now think about this in the context of time. Suppose we have a pair of entangled particles, one in the present and one in the past. If we alter the state of the present particle, the past particle should theoretically change as well. It's as if we've sent a message back in time. But how can we use this to simulate time travel? Well, scientists have developed what's known as closed time-like curves, or CTCs, to explore this. CTCs are essentially loops in space-time that could theoretically allow objects to return to their own past. In these simulations, scientists manipulate the entangled particles in such a way that they appear to behave as if they're in a CTC. Here's where it gets interesting. By simulating these CTCs, scientists can explore the possibility of changing past parameters. This doesn't mean altering history as we know it. Rather, it's about tweaking the conditions of past experiments at a quantum level to improve the results we see in the present. For example, imagine a scientist who conducted an experiment yesterday and wasn't satisfied with the results. Using a time travel simulation, they could theoretically tweak the parameters of the experiment in the past, improving the results they see today. It's a bit like editing a document on your computer. You can go back, change a few words or sentences, and suddenly, the whole meaning is clearer, more precise. Of course, this is all theoretical, but the possibilities it opens up for scientific research are fascinating. In essence, time travel simulations allow us to change the past, at least on a quantum scale. You might be wondering, what's the point of all this? Why should we care about time travel simulations? Well, let's dive into the fascinating potential benefits and applications of these simulations. First and foremost, time travel simulations can provide a significant boost to scientific experiments. How, you ask? Well, imagine a scientist conducting an experiment. They've planned it meticulously, but the results don't quite match the expected outcomes. Now, with a time travel simulation, they could theoretically go back in time and tweak the parameters of their experiment. They could alter their past actions to optimize the results in the present. This could revolutionize the way we approach scientific research, enabling us to refine our experiments and drive faster, more accurate discoveries. But the potential applications of time travel simulations don't stop at the laboratory door. Theoretically, these simulations could also be a game changer for financial market speculators and gamblers. Just think about it. If you could simulate going back in time, you could adjust your decisions based on the outcomes you now know. You could buy that winning stock, place the winning bet, avoid the poor investment. While this is purely theoretical at this stage, it's a tantalizing proposition for anyone involved in financial markets or betting. Of course, this all hinges on the existence of space-time loops and the ability to manipulate them, which is still a subject of debate among physicists. Yet the simulations conducted so far have given us a glimpse into how these loops could behave if they do exist in reality. So, while time travel remains the stuff of science fiction for now, the potential benefits of time travel simulations are very much grounded in reality. They offer us a new lens through which to view and interact with the past, which could yield significant benefits for science, finance, and beyond. Time travel simulations could open up a world of possibilities, from better scientific research to more profitable investments. It's an exciting prospect, one that could change our understanding of time and our place within it. While exciting, the concept of time travel, even in simulations, is not without controversy. The idea of moving backwards through the cosmic timeline stirs up a lot of debate among physicists. While most of the fundamental laws of physics are indifferent to the flow of time, the potential for particles to travel back in time is a contentious subject. The controversy stems from the fact that time travel, in essence, contradicts our everyday experiences. We're used to the idea that causes precede effects. But in the quantum world, things can get a little topsy-turvy. This is where the concept of space-time loops enters the conversation. These theoretical constructs are often visualized as a sort of shortcut through the fabric of space-time, allowing one to jump between different points in time. The existence of these space-time loops, however, is purely hypothetical. While we can simulate their behavior, proving their existence in the real world is a whole different story. But that's not to say it's impossible. In fact, some physicists believe that these loops could be the key to unraveling the mysteries of the quantum realm. As we move forward, the research into time travel and space-time loops continues to evolve. The potential of these simulations is vast. They could help us better understand the fundamental laws of the universe, and perhaps even uncover new ones. They could also have practical applications, from improving scientific experiments to predicting market trends. The future of time travel research is filled with uncertainty, but it's also brimming with possibility. The theoretical nature of time travel and space-time loops may seem daunting, but it's this very complexity that makes the field so fascinating. Despite the controversy, scientists are committed to exploring these concepts further, pushing the boundaries of our knowledge and understanding. Whether or not time travel becomes a reality, the research and simulations continue to push the boundaries of our understanding of the universe.